Today's Python Pandas video, we're going to be taking a look at how you could utilize rank. We're going to go through a lot of different examples covering topics like how to deal with null values. We're going to look at group by, as well as the different approaches on how to use rank, which is typical within interview types of questions. My goal is to make this the one rank video that you need to watch on YouTube. That way you clear this concept and keep moving forward with your Pandas education. So with that out of the way, grab a notebook and let's start coding. All right, so let's jump right into it. So we're going to start off with importing in pandas. So import pandas as PD and then import numpy as np. And we'll be using numpy for null values within this video. Pandas obviously for the ranking and our data frames. But before we get too far ahead of ourselves, let's make sure we create a data frame for this video. Now I have all of the code in the article linked down below in the description. So feel free to just copy and paste over our initial code. Although I recommend that you type out everything else. That way you get it ingrained into memory. So what we're going to be taking a look at today in particular is baseball card values. So what I'm going to do first is create a dictionary. I'll pass that dictionary into a data frame. We have a different player that's associated on the card itself, and then the price. And kind of fictitious on the prices. I just threw some stuff in there. Some of them are accurate, some of them are probably way off, but a lot of it also depends on the grade of the card. So we'll just pass that in over here, and then we'll just create a data frame from it. So we'll say df equals pd.dataframe, and just pass in our data, and now we'll have our data frame. Just to show you what this looks like, I'll go over here to df, right? So player, card, price, nothing too special. Additionally, we're going to make some copies of this because we are going to make some other data frames a little bit later. So I'm going to create df2 and df3. That way I just do it now instead of later. So df.copy, because we are going to be creating a bunch of columns with rank and it's going to get messy otherwise. So I don't want to have too many columns. I don't want to keep dropping columns in this video. So we'll just do that. We will add in additional columns a little bit later in the video as well, and rows. I'll show you what to do on that side of things. So no major concerns there. So what we're going to do now is look at our very basic example. So we'll say example 1, which is just going to rank every column in the data frame. Now I don't personally recommend this approach, but I'm going to say rank every column. You'll see some approaches that I recommend a little bit later in the video. But all you have to do on this side of things is just say df.rank. And again, this is just by default. And you can see it says player, card, price. It ranks it by the index that we have assigned. And we have a default index 0 through 7 on this side of things. You have 8 rows. I don't get a ton of information in here. I have to go back over here, right? I have to see the player, the card price, when you see df rank like that. Okay, so don't recommend this approach, but I did want to show you this as the first example. Our second example is just ranking numeric only columns. Again, I don't recommend this approach as well, but rank only numeric columns. It is useful just to show you this really quick, and then we'll spend a little bit more time on other approaches that matter a little bit more. So all you have to do on this is df.rank, and then we'll say numeric only equal to true. And what you'll see is now it ignores the string columns, right? So it ignores player, it ignores card, and it just ranks in particular the price, right? So if this index 4 is 1, and we go over here, index 4, and that's Derek Jeter, that's actually the cheapest. I'll show you how we can sort by, or not sort, but rank by descending order. So by default, right, this is ascending order with rank. So the smallest will get the first rank, the largest will get the last rank. Typically, when I do a lot of ranking, I do the opposite. I do descending order. But we'll just go through it like this, right? So we'll start off with that. And yeah, let's jump into different ranking methods and approaches. So what we're going to do is we're going to start with example 3, right? And what we're going to do on this one is create a new column, and we're going to use descending order. So this is where I'd say really start focusing on, because this is kind of where you see the application of rank used the most. So let's do that, right? So what we're going to do on this side of things is say df, and then we're going to use card value rank, and we're going to use the average approach. Now, the average approach is what is built in by default, right? And you can see we have 2.5, 7.5. So that is going to be default. All right, so what happens in this side of things for average is if there's a tie, it gets the average of the two ranks. So it is kind of important to just memorize these a little bit before jumping into some interviews because they will ask you sometimes these type of questions. Personally, I think it's not the best interview type of question because in the real world you'll just look it up. But sometimes they ask these on that side of things like lead code questions or stuff. So you will have to memorize it a little bit if you are trying to switch jobs or get your first job. But we'll go over here and say df price because it's the column that we want to rank. We're going to say dot rank, and I want to rank in ascending equals false, right? I want the most expensive card to have a rank of 1, and it trickles down from there. So ascending equals false, right? By default, it's in ascending order, so smallest to largest. I want to rank largest to smallest, so that's why I put ascending in over here. And again, by default, it is going to be the average rank, which we're doing over here. Additionally, we are creating a brand new column in this data frame, which is card value rank average. So we'll pass that in here. And what I'll tell you is we're going to go through all these approaches, and I'll show you the final data frame at the end. But just to show you what this looks like right now, since we created a brand new column, right, it'll populate over here. I'm not going to do it for everything until we jump into the end of all the different ranking approaches, but just to let you know on that. So now we're going to move on to our fourth example. I should mention, right? So why Hannes Wagner and why Ty Cobb have 1.5s, right? So on this side of things, right, these would be technically 1 and 2. So 1 plus 2 divided by 2, we get 1.5. And you'll see that there's no 2s on here. Again, we'll cover this at the very end with the different types of ranking approaches. But just because I populated this one here, I just wanted to show you that really fast. All right, so now we're going to jump into is our min. So another parameter we can use. So example 4, well, it's a method in over here. So example 4, min. And what min essentially does is ties get the minimum rank. What it does is ties get the minimum rank. And what I'm going to do is I'm going to copy this code because a lot of it's the same. We'll go over here and we'll, instead of average, we'll call this min. And then over here, we're going to still keep ascending equals false, but now we're going to add in our method, right? And over here, we'll just say min. Again, by default, the method is average. This one's going to use min. So we just have that over here. Again, we'll populate this at the very end. All right, example 5, will not populate, but show it. We're going to look at dense. Now, what dense is, it's essentially like min, but there's going to be no gaps in between ranks. So I'm going to say like min, no gaps between ranks. And again, I'll just copy this over here. And I'll call this dense. And you'll see this all at the very end once I go through these. I don't have many more to go through. So dense, we have that. All right, now we're going to jump into example 6. So example 6, and this one is going to be max, right? So we'll say max, and this is where ties get the max rank. And we'll just copy this code. We'll go over here and we'll go by max. I'll just change that to max. We're almost done. We have one more left. And we have max now. And then for example 7, which is going to be our last one, so we'll say example 7, we're going to take a look at first. And this is ties are ranked in the order that they appear. In the order that they appear. Man, my spelling is on point today. And all we're going to do is pass in first. So this will be your last one, and then we will print the data frame now that we have a bunch of new columns. So I'll just put over here first. Awesome. So now let's take a look at our data frame, and we can go over all these different approaches. So I'll just do a df head of 10, right? And here we go. So I'm just going to scroll over a little bit on this side of things, and this should be everything. Nope. Let's scroll over a little bit more. We don't need our strings really to showcase over here. All right. So card rank average, right? So let's use the approach that we have $1 million sale right here, right? $1 million sale. So these are both the highest amount of sales within this data frame. So what happens is they get ranked 1 and 2. You divide it by 2, right? So you get 3 divided by 2, you get 1.5. Now let's take a look at the min, right? So the $1 million, right? Highest sale, so that's a 1. But then we go down over here, another $1 million. Well, that's 1. Now we take a look at it. We don't have any 2, right? So it skips over the ties and then it'll go to number 3. So it'll go 1, 1, 3. So technically this is the third highest, right? Because we have 1 and then 1 over here. Now the difference is with dense, right? It treats these as the same, the 1 and the 1. And then we jump right into the second rank, right? So this one over here, 350,000. It's technically a third highest sale, but since over here that we have 2 that are tied in the first spot, it gets the second rank. Now, if we take a look at max, right, and I don't see this one used as much, we have 2 that are tied in that first spot, right? So since we have 2 that are tied in that first spot, they get spots 1 and 2. We go with the approach of using specifically 2, right? So you can see that there's going to be no 1 in this data frame. And then last, if we take a look at first, right, we have the tie over here between the million and the million. Well, the one over here is in the first index, right? Or I should say the 0 index, right? But it appears first. So that's why we have 1 over here. And this appears as a later index. So it gets the value of 2. So again, to just kind of reiterate, right? Card rank average on here. The average takes the 2 ranks and then divides it out, right? Minimum will take the minimum rank and then skip over the next rank. Dense, again, will take the minimum rank and not skip over the next rank. Max will take the maximum of the 2 ranks. And then first will take whatever is first and then assign the next rank to the one after it, even if they have the same value. So different purposes for each of these. Again, you'll be asked these within interview questions. Remember, that's just the method over here, right? So method average is by default. You don't have to specifically put that in over here if you want to see things in half, right? And then if you want to use the other ones, make sure you call either min, dense, max, or first. All right, so there's that side of things. What I want to show you guys now is percent. So we're going to change this up quite a bit. And let's jump into that. So example 8, which is going to be percent. And this is where we normalize the ranking so that they have a value anywhere between 0 and 1. So this is normalize rank to have value between 0 and 1. And yeah, let's jump right into it. So what we'll say over here is df2, and we'll say price percentage. And we're now going to use the data frame 2. Again, it's based off of our first data frame that we created. I just don't want to have as many columns, so that's why we created those copies a little bit earlier. But we'll go over here, df2, and we'll say price. And inside of here, we'll say dot rank ascending equals false. Again, because I want the highest sales to be first. And then all you have to do is pass in percent equals true. This is false by default, so that's why you see integers typically, unless there's a tie, right? Which you get a float. And we'll go over here. Well, I should say it's always going to be a float, but some of these, like the min, dense, will have you integer values. Regardless, what we have over here now is df2 price percentage, df2 price dot rank ascending false. So now what you can take a look at, if we look at the df2, right, we have our normalized ranks over here as price percentage, right? So hopefully that makes sense for you guys on that side of things. All right, so now let's look at null values. And what we'll have to do first is create a new row in our data frame. And there's also 3 different approaches to look at null values with. We're going to cover all of them. But first, let's build out our null value. So what we're going to do is create a new row on here. So we're just going to do it with loc. We'll pass in 8. And then over here, we'll just create it. Now, I didn't actually use a baseball card in this one. I actually used a non-sports card, but that's all right. So we're doing 1888 Lone Jack of Thomas Edison. So 1888 Lone Jack, and then just pass in a null value for the value of the card. So say np.nan, and let's get going. So there's a few different approaches, and we'll do the default one, which is going to be keep. So example 8, and we're going to call this keep. And essentially what this does is it keeps the null value as a null rank. And we should say like as a null rank. And like above, I'll show you everything once it's done. Right? So all we're going to do over here is df3, and we'll say card value keep. And we're going to say this equals to df3 price. And all I have to do is dot rank, and we're going to still use our ascending equals false. Right? There we go. And then what we're going to do next is look at top. So example 9, which is our top. And you'll also see the parameter that we use, which is going to be NA option. So we'll go over here and say NA option equals top. Option top. And actually it needs to be lowercase and in a string like that. And we're going to just put this tier to top. And also remember, I'm using ascending equals false over here, right? So that is an important distinction for you guys. And lastly, we'll say example 10, which is going to be bottom. And again, we'll just grab all this over here. We'll pass it bottom, so bottom, and then we'll pass it bottom over here. And yeah, let's take a look at this. And again, and we'll look at df3. We'll say df3.head 10, and check this out. So when we say keep, right, as I mentioned, we have our null value, right? Next, we're looking at top. So we have the highest rank over here with 1. And then out here at bottom, we have the lowest rank with 9.0. So that is how this works, right? Null value, 1.0, 9.0. So it really just depends on how you want to treat your null values. Now, personally, I think it's probably better to either like compute them or drop rows with null values or whatever approach you want to use fully before you go into ranking values. But if you have to rank before you can clean up your data set, this is where this becomes helpful. All right, now we're going to jump into a group by example. I do see this used quite a bit. So example 11, which is going to be our group by. And first thing we're going to have to do is add in a new column. So we're going to do it based off of what the card type is. Now, I'm not going to type this all out. So I'm going to say card type and then have all this here. Again, this is somewhere where you can just grab this from the article. Otherwise, just pause it and then just type it all out. But, you know, spend a minute or so, go up to the article, get the code for this, save yourself some time. So we have that now over here. So just to show you what this looks like, again, we could just go to df3.head over here. And you'll see that we have a card type, right? Vintage, modern, vintage, modern. And then what we'll do over here is just do a group by on this side of things based off the card type. So what we're going to do is over here, df3, say card type group by equals df3.groupBy. We'll pass in card type, then have our price, right? Dot rank, say ascending equals false. And I'm not even going to pass in anything for the null values. So I'm going to just keep it like that. And lastly, what we can do is just take a look at our final version of this, group by, and you can see we're going to have ties. So we're going to get 1.5, right? So the $1 million cards are both vintage. They have 1.5. And then you have this over here for modern that has a 1.5 because we have two modern cards that are the same value. Mike Trout and Shohei Ohtani, 2,500, 2,500. So they also get a 1.5. So you have a lot of 1.5s in here, right? And then modern you can see goes 3. And then there's probably a 4 somewhere over here for modern, unless it's the last modern one. Let's see, modern. Actually might be the last modern one. Vintage goes up to 4, right? You see 3, 4, and then there's another vintage with 5. So there is that side of things, right? And this over here, Lone Jack, Thomas Edison is still a null value. So group by, how you want to group by, right? The column that you're basing your rank off of. And again, I'm just passing in ascending equals false. So that's essentially the end of rank, but I did want to give you guys kind of a bonus because sometimes you'll see in interviews, they say grab like the top 3 with the highest rank or different things like that. So this will, I promise you, this will take like 2 seconds. And I just want to show you this because it might save you some time and impress your interviewer. But we're going to go to n largest. So what we can just go over here is df3 price and do .n largest and just pass in the value of 3, right? And you'll see it grabs the 3 highest prices, right? So you don't have to grab over here, or like you don't have to sort or do rankings just to get the 3 largest. So that's example 12. And we'll do the opposite, the smallest, right? And that's going to be example 13, which is going to be n smallest. And smallest. And all you have to do is go over here and just change this up. Now I might make a video on largest and smallest like this if there's enough people that want it in the future. We have a lot of pandas videos still to make, but you can see the smallest 300, 2500, and 2500. And yeah, that's essentially the video. So again, just to recap, right? You can technically rank your entire data frame. I don't recommend this approach. Personally, I think you should build out a brand new column. But if you want to, df.rank. Again, if you want to rank your entire data frame and only do numeric columns, just pass in numeric only equals true. Reality, you want to just create a new column in your data frame. That's the approach that I use at work. So what I'll do is create a new column name and then rank it. By default, you're going to be in ascending order. In this use case, you want to use descending order, largest to smallest. I often use probably largest to smallest more often than smallest to largest, but it really depends on your use case. So that's why I put an ascending equals false. Again, there's a lot of different approaches on how you could use rank, right? So you could use ties to get the, I should say by default, it's average. Then you can look at ties to get the minimum rank. Then there's a dense where there's no gap after. Then you have the max rank, which is going to be the largest of the ties. And then you have first, so whatever appears first will get that ranking. Then we went into percentage where it normalizes your rank value between 0 and 1. Talked about null values where you could either keep as null in the rankings or you could assign it top or bottom. Lastly, we covered group by, right? You can group by a column and still rank it. Find that very helpful, at least in the real world scenarios. And lastly, you have n largest or n smallest. Just to cover group bys, right? Like this could be an example of like, let's say you're a restaurant chain, right? And you have an operator that owns X amount of businesses. So maybe you want to rank all the businesses that the operator owns. Very quick example over there. I've never worked with food data, so I don't know why I did that, but I guess it's lunchtime and I'm a little hungry. Lastly, n largest, right? You can just grab quickly the X amount of largest or n smallest, the smallest on that side of things. Sometimes you'll see these used or asked about interview questions, and you can use this instead of rank. But yeah, that is essentially the rank coding part of this video. Thanks guys for checking out this video on Pandas Rank, and if you found it valuable, make sure to subscribe to the channel. Down below, you'll find links to the code from this video, our Discord server, as well as one-on-one mentorships, where that could be anything from career progression, landing your first job, or learning new skills, especially if you're trying to transition from a data analyst to a data scientist. I'm going to continue this Pandas playlist. Well, you can click onto it right over here, and I'll catch you guys in another video.